Lesson 15.5 is anti-differentiation involving arc trig. So remember, arc trig, arc sine, cosine, all that stuff is the inverse trig. On our calculator, you'll see like sine to the negative first power, cosine to the negative first power. All that means the same thing. I provided the derivative rules because I'm hoping you kind of remember just the gist of them. I never can memorize these other than arctan's not bad. I don't really remember these, but what I'm wanting you to see is that the derivative of the inverse tans were these fractions. Well, now we're doing the antiderivative, which is saying they're going to look like the answer to the derivatives were, so that when we antiderive, we get arc sine, arc cosine, arc tangent, all that stuff. And so it's not too bad with the formula, but I don't expect you to memorize these. We just kind of need to practice with how you would do them. So we're only using this side. So our first one is the integral of negative 5 over 36 plus 4x squared dx. First of all, I noticed that all our numerators have a 1 in them. So what I would like to do is factor out the numerator of negative 5 so that I have 1. Then I'm looking at what template does this look like. I have a number plus something with x squared. And I see that 36, or I should notice that 36 is also a perfect square. So just when we have addition in the denominator, that goes with arctan. So we're going to be using this one. Then I would rewrite so that this is something getting squared. So I'm going to put 6 squared plus, this should be something getting squared. So it's like I'm square rooting the 4 and the x squared, which would be 2x. That quantity, if it were squared, think of 2x times itself would be 4x squared. So that's why it's like this with parentheses around it. So then I'm able to pick out what my a is. So what number here is getting squared? 6. What value of x here is getting squared? 2x. And they call it your a and your u. Then I'm just going to follow this formula. So I had my negative 5 out in front, times the integral of this is going to get 1 over a is 6, times arctan, or inverse tan, of u over a, which is 2x over 6. Don't forget your plus c, your constant, because we're anti-deriving an indefinite integral. We don't have bounds to plug in and try to get an answer for. And the other thing I need to know is that when x is multiplied by a coefficient, I have to do that opposite of chain rule, which is dividing by 2 or multiplying by the reciprocal 1/2. So you can't forget that part. Whenever I see something in front of x, I'm dividing by that number. So then this would simplify, think multiply straight across, to negative 5 over 12 arctan. This simplifies to 1/3 x, or x over 3, plus c. Let's try number 2. Again, I don't want the negative 8 here, so I'm going to factor that out. So my integral has a 1 on top. Start looking for a template here, seeing where there's a square root of something minus something. Square root of something minus something. I'm seeing that for arc sine. So I want to rewrite this so that it's not 9, but it's 3 squared. And instead of 36x squared, that should be 6x quantity squared. Then I'm able to pick out what my a value is, which is what number got squared, 3. My u value is the 6x. So again, I'll have to divide by the 6 or multiply by 1/6 when I'm doing all my integral. Okay, so I've got negative 8 times, then I'm following the formula, arc sine. I don't have a 1 over a in front, which is nice. Arc sine of u over a, so that's 6x divided by 3, plus c. But again, I'm multiplying by 1 over 6. So negative 8 over 6 simplifies. You're dividing by a 2. That'd be negative 4/3. Arc sine 6 divided by 3 is 2x plus my constant. All right, and then last one. Take out your 8. Rewrite, so you got 1 over. This one's different because it has an x in front. But I'm still going to have to think what got squared. Well, that's x got squared minus 2 squared makes 4. Find the template that matches where it's got x times something or something in front. That's going to be arc secant. So we're actually not going to use arc cosine at all. because it's not going to help us. We're going to use arcsecant, and I can tell you that's the whole lesson is using arcsine, arctangent, and arcsecant on Delta Math. Okay, so I've got to pick out my A, which, be careful here, that's the second, that's still the number, the second term here in my square roots, that's 2. And then my U is simply X. So I won't have to divide by any coefficient there. So it'll go 8 times 1 over A, so 1/2, times arcsecant, the absolute value of U over A plus C. And 1/2 of 8 would be 4. And that would be my answer. So once you have the formulas, it's not too bad. Just make sure you're simplifying and don't forget to divide by any number that's times X.